All right. Thank you, everybody, for joining us here today. My name is Jonathan. This is my co-speaker, Sid, and we're going to be talking about tuning Tableau Server with our IAM performance best practices. Before actually get started, everyone had fun and data night out last night? Awesome. See hands go up, that's what we want to see. All right. So the gist of what we want to talk about here today is really based on this quote behind me. And we've all heard this or said it ourselves, where you comment, it's usually on a Monday morning, so think the next day will all be at work. And something got slow and nothing changed. However, often something may have changed, and importantly, it may be something that we as Tableau admins don't think about or don't have visibility into. It's like maybe in our environment or our data sources. So we're going to be talking about how we can measure these issues and what we can do to remediate them. So my name is Varkovitzky. I'm a product manager here at Tableau. I joined development back in 2012, so I've actually been part of the team for quite some time. To give you an idea, when I joined Tableau, we shipped two features, build maps, and data server, giving you the ability to publish data sources and share them to workbooks. So just think about how far we've come since then and what it would be like if we didn't have those features today. About 2 years ago, I moved to DC, so I don't know if any East Coast people out here today. Awesome, I see a couple. So yeah, I've had East Coast and West. Is this? Oh, you're not picking up the signal? Okay. Sorry about that, everybody. Is that better? Okay. So I moved to the East Coast about 2 years ago, so I've got a little experience on both coasts. But yeah, I've been with Tableau for a while, so I am a bit of a Tableau dinosaur. Been around, but yeah, outside work, I enjoy hiking anywhere I go for vacation, down here in the Southwest or elsewhere, dabbling in photography, and I'm on a sailboat racing team out in Annapolis, so anyone here's a sailor, stick around after the Q&A, and I want to have a chat. Okay, hand it off for you.
All right, I am Siddharth Likhate. I am a software developer at Tableau. I've been there since 2017, so it's going to be almost a couple of years. Actually, it was exactly a couple of years the day TC started. It's been a fun ride so far. My main role is dealing with customer performance cases. That's what I do every day. And I've been trying to work myself out of a job. That's right. I mean, trying to make sure that I don't have a job anymore. And the only way I can do that is to make sure you guys don't run into any performance issues. So hopefully the session today will give you the tools and techniques to troubleshoot and tune your Tableau server when it comes to performance issues. And we'll be around after as well for Q&A and stuff like that to answer any questions that you may have. Some other stuff about me, I went to Arizona State, love sports, music. I won't get into too many details, just feel free to talk to me about any of those if you want to. I'll hand it back over to JV, and I'll talk to you guys in a bit.
Thank you, Sid. So actually, before we dive into the agenda, I want to get a feel for who's here today and kind of the roles that you fit in. So we're going to do another hand-raising activity. I really like those. Get our heart rate up a little bit. So raise your hand if you are any of the following as I go down the list. So each one, raise your hand if it applies to you. Is anyone here a Tableau power user making a lot of dashboards? All right, see quarter hands, not bad, not bad. Who is the Tableau admin? All right, I see most hands, that's what we would expect. Glad to see that you're here. How many of you fall in that IT admin category? All right, I see a couple of hands. And how many of you are business leaders at your companies? I see one hand, excellent. So these are all different roles that are involved in keeping our server actually running and performing well. Now, my next question is, are any of you more than one of these roles? See, yeah, almost all hands. Who's all of these roles? I think I see one hand in the back. So the importance of why I'm asking if you're all of these roles is that all of these roles are going to be involved in the performance of our server, how things work, but generally we're not all of them. So the concepts and ideas we talk about today, you may want to take back with you to your organizations to share about IT policies, how you're setting up server, or even what content is published and shared on your server. So the overall agenda we're going to be diving into is we're going to start with some system-level monitoring tools. After that, we're going to dive into some Tableau-created tools. So specifically, we created for monitoring servers that are running Tableau. And then after that, I'm going to be discussing what are the knobs that you can turn and adjust that impact that performance and make Tableau Server quick and snappy for all of your users. As Sid said, at the end we're going to have some time for Q&A, so please write down and save all your questions. We'll be more than happy to take them during the Q&A, and even if we run out of time after Q&A, Sid and I can stick around and chat. So I want to go ahead and dive in, discuss these tools of the trade. So the first one is Perfmon. Again, I'm assuming some people have used Perfmon before. I see a couple of hands. So for those of you who aren't familiar, it's available on all Windows machines, so it's going to be easy for you to get a hold of. It gives you access to hundreds of metrics, so rather than just pulling up Task Manager and seeing CPU and memory, you can actually select a whole host of metrics all the way down to disk queue length, CPU, cache time, things of that nature. You can configure how often is it sampling these values. It's easy to save these results. You can even choose how long it's saving. You can set up a circular buffer and only have it save when something of interest happens, so you're not building up months and months of records of nothing interesting. So it's a great first pass tool. You install it on each server, so it's really nice to have. As I said, it's on all Windows machines, before that, if anyone is running on Linux, you can use the system activity reporter to essentially collect these same metrics and save them over time. Now, this, for the Windows tool, it's been around since 2006, so if you have not updated Windows since 2006, there's a separate issue beyond the scope of this course that you may want to look at. But this was also the year that the International Astronomical Union kicked Pluto out of our solar system, and the year I canceled my subscription to their newsletter out of how upset I was. So next, I want to jump into now some of the Tableau-specific tools, now that we're on the same page with Perfmon. So there's a tool called Topmon. I see show of hands, are people familiar with or have installed it? Okay, I actually see a good number of hands. That's really great to see. So Topmon is created by Tableau, and it utilizes Perfmon under the hood. So all of the advantages of Perfmon, where you can choose what you're measuring, how often you measure it, you can leverage all of those things. But one big advantage is you can monitor multiple machines at the same time. So you install Tabmon, say you have multiple node deployment, and again, see show of hands for multiple nodes. Okay, about half the room. So you don't have to set up and check and collect monitoring off of each machine. Once it's installed, it pulls all of that information to a centralized location, and you can monitor from there. Behind me, you can also see we give you the results in a Tableau Viz. We call out which activities are happening based on which Tableau process, and also if there are any specific actions happening on the server. So it's really great to correlate, say, a spike in background or activity to a spike in CPU. Tabmon's a great tool to help you start that investigation. Yeah, so we have all these additional hooks, and that's how you get this visualization. If anyone who hasn't used Tabmon wants to learn more, please go ahead and scan this QR code. So this links to the GitHub page where you can download Tabmon, and on the GitHub page is a whole host of documentation. I'm going to leave it up. I still see some cameras. If you can't grab the QR code, that's totally fine. We give the deck out after conference, and there's a secret slide in the back where we wrote out all of these URLs. So feel free to wait, and you can grab it from there as well. Next, I'm going to have Sid come and talk to you about, frankly, my favorite tool that we developed at Tableau called LogShark.
All right. Thanks, JV. God, you're fine. So I'm going to talk about LogShark today. There's a variety of things that we're going to go over, but before I start talking about it, how many of you have heard of LogShark or have used LogShark before? Well, that's great. So there's quite a few that have heard of it, that have used it. And I think you'll all be pretty excited because there's a couple of new things that I am going to share today about LogShark. For those that haven't used it, LogShark is a tool that basically takes Tableau logs as input, it parses them, and generates Tableau workbooks as output. Those Tableau workbooks can give you insight into Tableau Server operation. I like to think of that as operational insight. So there's a variety of information that you can get from those workbooks, including what are the most famous, or what are the most famous, I should say, well, what are the most frequently accessed workbooks and data sources on your box, or what tasks are consuming the most resources. You can get a whole host of information from the workbooks that LogShark generates. LogShark is free. It's available on GitHub. Anybody can go and download it and start using it. One thing that I'd like to highlight today is a new version that we released just recently, a few days ago. You'll see that there's an announcement on GitHub, and I have links to that in the slides later, that there's a new version that's out, and the one big thing in this new version that we have felt has a huge impact to our use of LogShark is performance. So we have seen Well, when I say performance, it's not like we have gone and tweaked a few minor things and gotten a 15 to 20% improvement. This has been a pretty big rewrite of how it operates under the hood, and we've seen at least 10 to 15 times improvement in processing speed. So things that used to take hours earlier now take minutes. And just because of this, I think internally we have seen a lot more adoption of LogShark within our company as to how we deal with cases. And we are hoping that when you guys download the new version and run it, you'll be able to see the improved performance. The other thing that we released, which is new, is an activity and resource tracing workbook. I should say new version of the activity and resource tracing workbook, because that workbook was available even in the previous version. But there's a lot of new things that we added to this, and we feel that it'll generate a lot of value. It generates a lot of value to our analysis of performance internally, and we're hoping that you guys can get the same value out of it. So before I dig into more details around what this new workbook is, what is activity and resource tracing? So at a high level, you can think of it as a framework that gives information, or that logs information around elapsed time, CPU consumption, and memory usage for each activity. So with this information that we capture in the logs, we can parse that information and build really insightful workbooks out of it, which is pretty awesome. And I'll be showing, demonstrating the art workbook in detail over the next 5 or 10 minutes today. And we'll see how that all looks like in a live demo. So what are some of the questions that our new activity resource tracing workbook is attempting to answer? So how many of you guys have had scenarios where customers or users of your Tableau server come and say that, hey, I loaded this view yesterday and it was super fast, and I just loaded the same view this morning and it's like twice as slow. What's going on? And that's not an easy question to answer. It doesn't really, many a times it doesn't really have a single answer. But one of the challenges right now is that there is no easy way to go and look at those two user actions and do a single click comparison of them and be like, okay, here's what's different. And that's one of the things that we are hoping this art workbook is going to help answer. The other question that a lot of the Tableau server admins have is, what about my query performance? In general, when my users are doing actions on Tableau server, issuing queries, clicking on filters, or making selections, what kind of queries am I running, and how are those queries performing? Because every time you have a query that runs slow, it directly impacts view load time, because we need to wait for the query to complete and for the results to come up in order for you to see the viz. So the workbook is going to give you information around whether there are queries that are showing intermittent performance, because we've seen in many cases where there is a single query that runs fast at some time during the day, but the same query a few hours later just takes longer. And that's something that is very useful to have. And when you have this kind of solid information available, you can take it to your DBA and show it to them and be like, hey, so this one specific query, can we do something to tune it better? Why are we seeing this? Are you seeing the same thing at your end? The other thing that this will help answer is the resource part of the question. When I said activity and resource tracing, the cool thing that this does is it actually records detailed CPU and memory level metrics for every user action. So you can actually get deep insight into whether there is a certain set of user actions or a certain set of workbooks that are consuming a lot of resources on your Tableau server installation. And finally, the nightmare, I guess, for every Tableau server admin, you get users start complaining about, I'm seeing things error out and what's going on. I clicked on this filter and I just see an error dialog, and I tried to load this view and it's not giving me what I'm looking for. So there's a viz that we created just for focusing on errors that will tell you exactly where the error is happening. So some of the content here is going to be heavy, and I'll try to go into as much detail as I can. But one thing before I start, I think a lot of the demo vizzes that you guys are going to see today are going to involve this one kind of viz, which is called a Flamechart, which is why I wanted to pull it out separately and talk about it. So you'll see this Flamechart viz being used all over the place in the activity and resource tracing workbook. So I wanted to give you guys a high-level overview of what it means. So you can see multiple different bars here of different sizes. One thing is each bar here corresponds to a single activity. So the whole view that you see here is of a single user action. You can think of it as an X-ray view into a single user action. Each bar that you see on this visualization is a single activity that was performed in order to in order to get the user what he was looking for. The length of the bar is proportional to the elapsed time. So the longer bars are basically activities that took more time. And this helps you give a visual way of identifying long-running activities. And we use that a lot when we are trying to drill down on specific user actions. You'll see this viz showing up a lot in the demo. The other thing to keep in mind is there is this concept of depth, where as you go lower down the flame chart, the activities that are lower down are basically children of the activities that are higher up. So any bar that you see higher up has spawned the bars that you see lower, or they're children of that higher up activity. All right, so time for the demo. Let me switch this. Okay, so the first of the many Vizzes that I'm going to demo here. So what you're seeing here is essentially a plot graph. This is a log snapshot of a 4-hour execution from one of our internal Tableau servers. So I took logs that were worth 4 hours of Tableau server execution. I ran them through LogShark, and it generated this workbook for me. I was very fast. So each mark here that you see on this plot graph corresponds to a single user action. So you can see that I've filtered it down. There were a lot more user actions there. I've filtered it down to make it easy for me to demo it. But you can see right off the bat that there is a color encoding there. The color encoding is based on the type of the user action. So all user actions of a particular type are given the same color. And the y-axis, or the marks that are showing up higher on the plot graph, are basically user actions that took longer time. So the y-axis is the elapsed time, and the x-axis is the timestamp of the user action. Now the cool thing is that with activity and resource tracing, like I mentioned, it can give you insight into exactly what happened when it came to each user action. So you can click on this mark here, and I'm going to click on this right here, and there is that X-ray view of what exactly happened underneath. You can click on all the marks that you want, and it will give you this single-click visualization of all of the activities that happened in response to that single user action. In this case, the user action that I clicked on was a view load. So the user just loaded a view, which is like the most natural thing you do in Tableau. And here are all of the things that happened as part of loading the view. Now, if I scroll down on this flame chart, you can quickly see that at the lowest level, there is this long green bar here. And interestingly, this green bar actually corresponds to query execution, right? And there is some documentation that we have online around what these activities refer to. But right off the bat, you can see that, okay, it looks like more than 50% of the time for this user action was spent in executing the query, which is useful to know. And there's, you'll get this kind of insight into all of the user actions. So this is a really nifty tool. We use it a lot for handling customer cases. The other interesting thing in this flame chart view is the capability to click this radio button, and you can quickly switch into a CPU-based flame chart, where now if I click on this, the color scheme is going to switch to a spectrum-based coloring, where the red bars are the ones that are more resource intensive from a CPU standpoint, and the green bars are the ones that are not as resource intensive. So again, with a single click, you can get quick insight into, okay, which pieces of the user action were heavy consumers of CPU. Now the next one that I wanted to demo was trying to answer this question of, I performed this user action yesterday and it was fast, and I do it today and it is not as fast. So what's going on? So again, you see the same plot graph here. Each mark here is a single request, and I've filtered it down to a single user. So if you look here, there are user level filters, because when you're doing comparison of user actions, you want to make sure that you're comparing the same workbook and view load for the same user, because it could be different for different users. So if you want to get an apples to apples comparison, you need to filter this to that detail. And I've filtered it down, And these marks are basically showing me that there is some variability in performance when it comes to the same view load for this same user. The cool thing is, I can click on any two of these marks, and I have the session comparison link here, which I can click on. And in one click, it's going to just give me detailed information on comparing the two sessions. So on the left-hand side here, you can see the flame charts that are stacked one below the other to give you a visual way of identifying what was longer. And on the right-hand side, you see that we have sorted this based on the low-level activities that showed the most difference in the elapsed time. So the ones that are showing up on top are the ones that showed the most difference in the elapsed time. And you can see that because, when you hover over it, we have this nice highlight feature that's highlighting that activity in the flame chart, and you can quickly see what's going on. The other thing which we think is cool is the fact that you could compare cache hits between these two user actions. Because sometimes one request is slower or faster just because it hit or missed certain caches. So just clicking on this button is going to tell you which particular caches the user action missed or hit, and you can again get a comparison between the fast and the slow version. Sometimes it's just as simple as, oh yeah, you hit the query cache, so you didn't need to issue the query at all, which is why you were faster. So this is just one way for you to get that kind of information quickly from your logs. The other one that I wanted to show is this intermittent query view. And this one is pretty interesting because many a times, we end up spending a lot of time debugging or triaging a case where we are trying to figure out, hey, what's going on? Why is this slower? And after spending, a significant amount of time, we just look at the logs and we're like, oh, well, here's this query that for some reason just ran, same query, just took much longer to run. And then we got to go back to the customer and we're like, hey guys, so you have this XYZ database that we ran this particular query against, and it so happens that at one time it took 10 seconds and the other time it took 40. So that's why your Viz rendered slowly. So our goal is that with this kind of information surfaced through LogShark, you guys would be able to get that kind of insight yourself. Again, the same plot graph that we have here, but the interesting thing here is that all of those dots that you see there in the lower Viz are all the same query being executed. And the y-axis is the elapsed time for that query. So you can see that initially on this side, this query showed a lot of variability in performance. And then after a while, it kind of stabilized and it started executing much faster. One of the reasons for this could be that there is caching on the database side, and it's probably figuring out that this query is going to get executed multiple times, and it's gotten smarter, and it's cached a lot of the stuff so that later executions get faster. But that's very useful information to have, and you can get this information for all different kinds of queries. There's some color encoding that we put there, where the dots that are colored red are basically the outliers when it comes to that particular query. So if that query executed and it took a long time to run, we color it as red. If it took slightly longer to run, we color it as yellow. Otherwise, it's green, basically. So that's one way of getting this kind of insight. And keep in mind that there's nothing stopping you from modifying some of these workbooks to fit your needs, because LogShark has a way to even generate custom workbooks for you. So you could generate your own workbooks based off of these and store them somewhere, run LogShark, and you're going to get those at the end of the LogShark run. The final one that I wanted to demo was this resource-intensive request plot. And I personally find this interesting and exciting just because of the fact that this is the result of the resource logging that activity and resource tracing brings to the table. So with a single view, you can see all of the outliers that you're seeing at the top right there are basically user actions that took up a lot of CPU and a lot of memory on your server. Because the X and Y axis that we have here are basically CPU and memory consumption. So anything that you see far right top is something that you want to investigate and understand. And the color encoding here is based on the workbook and the view. So it's pretty clear right off the bat that there is one particular workbook and view here that is taking up a lot of the CPU and the memory. And you can hover over it and it's going to give you a tooltip with details around, what the workbook name and username was, and clicking on it gives you these flame charts again on CPU and memory consumption, on which particular pieces of those user actions were heavy on CPU and on memory. So we saw this earlier. The ones that are colored in dark are the ones that are heavier on CPU than the ones which have a lighter shade, and the same for the memory. So it's just useful information to have in terms of, okay, which aspect of this user action took up a lot of memory. You can get that pretty quickly from these views. So that brings me to the end of the LogShark demo. There is multiple other views here that I'm not going to get into the details around, but documentation for all of these is already available on GitHub, and the new art workbook is available for download as well, along with the new LogShark version. So you can go and download this today and start running it and getting more insights from your Tableau Server logs. All right, so here is the QR code if you guys want to have the link to the latest LogShark version. Again, the link's going to be available later in the slide. The next thing that I wanted to talk about was performance recording. So you guys know that there's a performance recording feature in Tableau Desktop and in Tableau Server, and I'm sure many of you guys would have already used it. One thing that I wanted to talk about here was a new and improved version of the performance recording. We added a lot more detail to the new version than what was previously there, and I'll go over that a little bit. But first, a very high-level overview of what a performance recording is for those who may not have used it or may not have heard of it. The cool thing about the performance recording is that it's built into the product, so it's just available whenever you install Tableau Desktop or Tableau Server. There is a user-triggered start and stop that basically allows you to focus on a particular scenario. So if there is a particular scenario that is slow, you could click on the start recording button, perform the scenario, then click on stop recording, and the end of it is going to bring up a nice little Tableau workbook that summarizes all of the actions that you performed and which actions took the most time. The output is a Tableau workbook. We love using Tableau. We use it a lot. The other thing is that it's very easy to package up and send. So this is one of the most frequently requested resources when it comes to a customer performance case. Very often we end up requesting the customer to do a performance recording and send it over to us. And internally we end up analyzing it and trying to figure out what is going on. This is a snapshot of the existing performance recording. For those that haven't used it, there's a timeline view. There are events that we log there. You can click on a particular event and it'll actually give you the SQL query that was issued to the backend database, which is pretty cool. There's a new detailed view that we released. So internally, the way it used to work is when customers used to send us a performance recording, we had this detailed view stashed away somewhere. We used to just take the data from the recording and put it into the detailed view for our internal analysis. But we figured it would make sense to just make this available to customers as well. So there's a new detailed view, and again, you'll see the famous flame charts. We love flame charts on the top viz here, and the one below is basically just a summary of the activities and the number of times that particular activity occurred. So we feel that this gives more insight into what happened, which is why we're going to be making it available in an upcoming release. All right, so that brings me to the end of the performance recording and LogShark part of it. I'll hand it back over to JV to summarize the tools and then go over the knobs that you can turn for tooling Tableau Server. Thanks.
Thank you, Sid. So to review the tools that we discussed, just to give you that last minute refreshers, we started off at Perfmon, just monitoring the performance on a single machine. After that, we looked at using Tabmon to monitor CPU, memory, and a whole host of other metrics across all of our machines and reporting it to a single place. After that, we talked about LogShark, which is really, it's just my favorite tool. And I actually have a short story about LogShark. So I was on the team when we were writing LogShark v1. The version we released last week was v4, so it's been a little bit of time. But as an engineer, I was really excited about that functionality, and it didn't look like they were going to be able to finish it. It was going to take several more months. And so I knew I needed it that day. So I started writing my own, not quite as fully featured version, but it was a Python script. It scraped logs and it made some Vizzes, and I called it Logfish because we already had the name picked out. But I was really excited about it, and where we are today blows all the old stuff out of the water. And at the end, we talk about performance recording. So once we've identified, in the case specifically of a workbook that is running slow or using up a lot of resources, we can use the performance recording to really dig deep and figure out what the issue is there. So as Sid said in the beginning of his section, a lot of this was a lot of heavy content. Some of us may also be a little bit tired from yesterday, from data night out. So I want us to just take a minute and relax before we move on. And I just want us to have a nice meditative moment here together. So if everyone can follow along with me, I'd like you to close your eyes and close your browsers. I'd like you to populate your cache and breathe out. I'd like you to reserve your CPU and breathe out. Now allocate yourself some RAM and breathe out. All right, please open your eyes. I hope you all feel a little bit better, a little bit more rested. And now that we've discussed how we can monitor and detect what performance issues are happening, let's dive into what can we do about it. So there's a whole host of knobs that you can turn, as Sid was alluding to, and I want to walk you through those and show you what they are. So as I said, there's a whole list here. We're going to be going through each of these ones individually. So let's go ahead, strap into our Apollo lander here, and take a look at those controls. Now, for any of you who went to Devs on Stage yesterday and saw we have new and exciting features, these controls might look a little bit antiquated. And as somebody who's worked with customers, I like to go on site and help them out, but you can pull out now and use your tablet, get to those admin controls and make adjustments. And here, I'm able to work remote on the tablet, and you can see in the next room the customer's happy and everything is going smooth. So I want you to know that I'm bringing you that experience here today. So the first topic I want to discuss is workbook design. And this may not be the first thing you think would be a performance issue. This is an admin session. Most of you are admins. But workbook design can have a really big impact on your server because that's the content that's being loaded and potentially loaded a lot. So for a nice high-level thing is to just reduce filters that exist on the Viz. It's tempting when we're creating a Viz for the first time. We want to be able to filter and drill down by every dimension and measure. While that can be good, it adds a lot of complexity both to the workbook, but it also adds a lot of complexity to the queries that we have to send to our backend database. You also want to ask yourself, how many marks are needed on these Vizzes to still be effective? A modern high-end monitor, say the one we have on our desks at work, might have 5 million marks. The Vizzes Sid was showing, each of those marks is hundreds of pixels. So you can only have so many marks and still be getting value. But if they're on the Viz, we have to calculate them, we have to render them, we have to draw them, and that's adding work. So reducing it both improves the ability for users to get value and understand what's happening in the Viz, but it's also helping Tableau be more performant. You want to avoid massive crosstabs. I know a lot of people here work with people who like the traditional crosstabs, a data table to be shown. And those are fine and Tableau supports them, but sometimes there are hidden performance issues. I had a customer I was working with. They had a workbook with several filters on top, 8 columns, seems normal. We can all read a table with 8 columns. But it had 4 million rows when you loaded the view the first time. So if you think about it, each cell of the table contains a number, a word, maybe a short sentence. So it's like a word's worth of information. So they were loading, in that case, 35 or 40 million strings worth of data every time they open their workbook. And that goes to the database, gets queried, gets sent back to Tableau, processed and rendered and drawn. But when you think about it, the Lord of the Rings trilogy, so a nice good amount of reading, that's 450,000 words. So chances are you don't load your Viz and read almost 10 or 20 or 10 or 100 times more than that in a single view. So having intelligent initial settings on the workbooks, filtering that down, made that workbook go from taking over a minute to load to basically being instantaneous. And of course, you want to optimize with these things all of the popular content. Does anyone out there have a business that has a quarterly sales dashboard of some sort that your salespeople might look at the end of the quarter? I feel like every company I work with, they have that, and that's pretty popular. But saving just a second of view load time on a view that might be loaded 1,000 times in a day by your sales team, especially that last day of quarter when they're all checking, that could be a lot of load on your server. So making even small reductions can really have a big impact. Now, if anyone wants to learn more about workbook design, really dive into it, there's a QR code here for a Tableau white paper called Designing Efficient Workbooks. It is a very detailed, very in-depth white paper. You can go, it has sections so you only need to read about what's relevant to your workbooks, but I really recommend it if you or anyone in your organization is interested in learning more about this topic. See one more camera up, I'll give them a sec. All right. The next topic I want to discuss is working with database design. As some of the Vizzes Sid showed, query time can be a place that we're losing a lot of time during our loads, so it's something we want to make sure is optimized. So the first step is go and befriend your DBA, if you haven't already. I'm sure they're nice and they want to work with you because you are co-customers of each other. Here, I have an example data table, and the first step is obviously index by anything that's commonly used in your workbooks. Your DBA may already be on top of this. When you're calling data from Tableau, though, try to use data source filters in two ways. The first one is to reduce the number of columns that you're pulling. So this has two big performance hits for Tableau if you have too many columns. For certain data sources, even just sending the metadata request to get the headers, if you have hundreds of columns, can be expensive. But the other thing is, if you're requesting all those columns and then you just never use them in your workbook, that the information is aggregated and sent over the wire so that Tableau could use it if it was needed. But if you don't need it, save yourself the query and transit time and cut that short. And of course, also use the data source filters to cut out rows you don't need. So again, using that quarterly sales example, if your company has a decade of sales records, you can go ahead and at the data source filter level say, only give me the last 3 months or the last 2 quarters if you need some flexibility. But if you're just filtering in the Viz, it still requests everything, returns it, and then filters it once it's rendering the Viz. But if you do it in the data source level, then that information never has to come over the wire from your data source. And the last tip is you can materialize any tables in your data source if it's for a high traffic or high visibility view. So a great example here is if your CEO or CTO has a Viz that they load on their tablet every morning, you can, if you want, make a materialized table that you have one row of data in that database that correlates to each mark on the Viz. And that's going to be really fast. There's going to be no time aggregating information, quick over-the-wire action, and that can really be a big win for you. The next thing I'll discuss is optimizing the extracts that you're using. So we're keeping our data example here, but I'll just go over kind of showing some of the advantages from using extracts. So first of all that data is localized onto your server. So as long as your users want to have the data extracted and your policy allows you to have it localized on the server, you're again saving time over the wire because the data is right where the rendering is happening. You only keep the data you care about because we went ahead and we cut out the columns that we weren't interested in. We were able to filter out the rows we didn't need, and we're keeping that more small and compact piece of data that we want. We're also reducing any load on our live data sources. You have 1,000 people, again, I really like the quarterly sales dashboard because we all have one. You have 1,000 people hitting that, that's a lot of load on your SQL server. But if it's localized on Tableau as an extract, it goes right there, it's in the local cache once the first person looked at it, and things are faster for those users, and you're not hitting that database over and over, potentially locking things up. You can also use extracts if you need to hide any rows or fields. By doing some of the methods I've shown here, you can hide a column that maybe should be private, or you can exclude data that you don't want your users to see. Maybe it's erroneous or whatnot. And you can also materialize your calcs by having it in extract form. So if you have any complex calculations in your workbook, those are pre-calculated when you create your extract and when Hyper runs each time. So especially if you've got complex string calculations or nested calcs, all those can be done ahead of time, and then when you load the view, essentially the answer is already there to be shown. It doesn't have to do the work behind the scenes. So all those together can make a pretty compelling argument for when you want to use extracts. So now, moving into the more traditional Tableau admin space is modifying our Tableau topology. So the first recommendation that many of you have probably heard is that you want to localize your nodes together. I saw a number of hands for multiple nodes. So you want to have them on the same subnet. But also, there are other considerations. And I want to, again, share a story from my time working as an engineer of a customer that was based on the US East Coast. They had a 4-node deployment, and they had an ongoing support case with a performance issue that roughly a quarter of the time their Vizzes loaded poorly. And I mean like randomly, 1 out of 4, not in the morning it's slow. Just if you just sat there refreshing, it was kind of strange. And so I actually ran LogShark. I was looking into things, and I was trying to figure out what could go wrong. And I actually ended up changing the Viz a little bit and coloring by worker number to see if there was an issue with the machine. And I noticed that worker 2 had all the slow loads. 100% of the slow loads were in worker 2. Worked with their IT team. We were trying to diagnose disk issues, network connections. None of that was the issue. with an offhand conversation that we did notice something that I had not thought to ask. Worker 2 is in the Netherlands. So any request that happened to go to that machine, because of where their IT had allocated their box, only had to go over the transatlantic cable twice to send the request and then bring the result back. And that was impacting their users every single time they wanted to load a view. And this is just one of those things that you're probably thinking that's not an issue for us, and it might not be, but there are these issues that can exist on our server that are so outside of our scope as admins that we don't generally think about it. So we should keep our minds open to think what in our environment could be impacting us. The next tip, more Tableau specific, is isolating your backgrounders. So for those of you who have one node today and are maybe thinking of moving to more, this is a very big thing when you have extracts running during the day, during the workday when people are loading Vizzes. There's going to be competition for CPU cycles. Extracts are going to be running, creating those files, but on the same computer, or the same server, pardon me, people are loading Vizzes and we're trying to render images and serve those. And if those are competing, now people are sitting and waiting because of that other job. If you can split these up, all the backgrounders can run on one worker, all of the Viz loads can come from the other machine. And even if this ends up causing the backgrounders to be a little bit delayed, in my opinion, I'd rather have an extract finish 1 minute late than have my users wait an extra 15 seconds watching a Viz load. So splitting those out is a really big win, especially for those people moving from one node and beyond to start. Another configuration you want to think about has to do with VizQL server. So this is kind of the heart and soul of rendering and preparing the Vizzes. If you go in your admin view, you can see the different processes. We recommend having at least 4 cores for each VizQL process. This is a highly parallel process. It's doing a lot of work. If you have too many of them on a machine, they end up competing for resources, and there's more issues with context switching than actually moving any content through quicker. So keeping about that ratio is a good thing to keep in mind on the machines that have VizQL processes. Another thing, Sid was talking about cache hits and misses, and everyone loves cache. If you can get a cache hit, it's going to be a faster query 100% of the time. But having more caches is not better, and that's something we kind of intuitively think. And I've actually come across customers that had 16 cache servers per machine. And the cache servers don't use up much resources, that's not the issue. But you end up with 16 copies of the cache on the machine, all ready to serve the data at any moment. So if any of you have wanted to expand the cache you have on Tableau, there are actually some TSM settings in our documentation that you can look at, and instead you expand the size of the cache, or you extend the timeout. So essentially, when something is put into cache, if no one accesses it, it stays there for about 30 minutes as the default. You can extend that if that works for you. Or the default size is about 1 gigabyte. If you know that you have query results that are very large and that's not going to hold much for you, increase the size. And that's where you're going to start seeing some benefit. Now, the next topic, moving a little bit away from Tableau and back to our environment, has to do with VM resource allocation. Could I quickly see show of hands of who runs Tableau on some sort of VM? Okay, I see about a third or half. One moment, please. So I want to say at Tableau, we love running on VMs. We use them internally. I would say about half of our customer base uses them for server, and there's something we definitely support, but there's some important things to keep in mind. The first one is that Tableau is a compute-heavy application. As I was talking about with VizQL, with running these queries, it's not just that we're rendering a Viz and sending it. There's a lot of work happening on the back end. We don't always intuitively remember that, so keep that in mind that these VMs are going to be doing a lot of work for you. The recommendation here is that you want to reserve both CPU and memory on those VMs. And VMware, as an example, actually recommends 100% reservation for CPU and memory for compute-heavy applications like Tableau. And the thing I want to call out, because when I bring up these points, a lot of admins aren't super excited, is that you're still sharing here. By reserving it, you're not blocking out other applications from using these resources. You're just saying, these Tableau VMs, they get the first choice of these resources. When somebody's loading a Viz, I want them to get the resources before, say, my email server sends that email out. Because we really want to value the time that people are sitting and waiting at their desks. We want to reduce that. I want to emphasize we're going to reduce sitting and waiting. So keep that in mind with your VMs. And again, if you want to see that VMware white paper that references that, we have a QR code here. Again, the URL is on the back. On the last slide, and all the slides are available after conference. And before I move on though with VMs, I want to talk about an experiment we did. So we were curious internally at Tableau to see how does allocating these resources actually impact throughput. So throughput being the number of views a user could load in a given amount of time on a server. So we set up a VM host, two VMs, one running Tableau Server with our performance suite, and the other one having general hardware testing to just use all the resources in the world that it could. We started with 0% CPU reservation, and then we slid that up slowly and saw how did it look as we incremented forward until the two VMs were sharing the host equally. So here I have 4 theoretical outputs, and there's going to be kind of a show of hands here for what that curve of the throughput looked like as along the x-axis we increased reservation. Who thinks we had the performance of the top left with that like nice linear line growth? So every bit of reservation you get more throughput? All right. How about the top right with that nice smooth curve? Okay. Oh, no, don't want to give away the answer too soon. How about the S curve on the bottom? So there's some diminishing returns and inflection point. Okay, I see a number of hands. And how about that last choice in the bottom right where reservation didn't matter and throughput just stayed steady and at 100% the whole time? All right, so no hands on that one. I know we all want that to be true. That's a separate question for later. So the actual results. So we ran these tests internally, and the results came out kind of like the third choice with that nice S-curve profile. And I actually want to call it an important point here. We see that there's an inflection point, and the more reservation, the better. But all the way on the left, you would intrinsically think you have 2 VMs, they're fighting for resources, you're going to get half of the throughput roughly. We actually found that we got only a third of the throughput. It's actually 34%. But just think about that. By not doing any reservation and letting the VMs share equally, you got 17% less throughput than even perfect sharing would be. This has to do with issues around context switching, warming the cache on the actual CPUs that the host is running. So it can be really expensive if you're not reserving the CPU for your user experience. Because you're getting 33% speed of the loads of views. So that's that eyeball time of your users. The next few slides I want to talk about antivirus. I don't even need to do a show of hands who of us has it on our corporate environment because we all do. And if we don't know we do, IT put it on there already. It's ubiquitous. It can cause performance sinks depending on how it's configured. It can show up in many of our customer cases, and I would say in at least 20 to 30% of the performance cases I've worked, some component has to do with hitting antivirus, the scheduling of things. Often it's going to be scans that are happening, so the traditional antivirus scans, active or passive, but it could also be filter drivers that are checking to make sure any executables on your system are safe, being checked every time that you're running, say, an event on your server. We can, and I'm going to talk briefly about how we can schedule things to remediate this, and also how certain folder exclusions can make an impact here. So first, for detection, we're going to see intermittent and sporadic slowdowns. So you're going to get those reports if it was slow now and it wasn't before, and using those Vizzes that Sid was showing, you'll actually be able to see it pretty clearly. You'll see spikes where all of your views were kind of slow for a short period of time, then it sank back down. And there may be no pattern to when it's happening. You'll see also, using some of our monitoring, unexplained CPU spikes at different times of day. That could be the antivirus running and actively scanning through entire directories on your system, using up those same resources, making it so your users can't load views. If you're looking at those active and passive scanning, a tool like Perfmon on Windows is going to simply show you that it's running at that time. Now, unfortunately, filter drivers can be a little bit harder to detect. There's a tool called Windows Performance Recorder, which you run on your system. It actually provides a Flamechart. It's not made by us. Other people just really love Flamecharts too. And as you're looking at that, you can actually see the time spent where the filter driver may have been blocking the execution of code which was needed to render your viz. Now, to remediate this, we have a couple of choices. So first of all, you have to befriend your IT admin, just like we befriended our DBA a few slides ago. And this is important not just because they're going to help make changes, but they may know about the settings and the policies that us as admins don't intrinsically think about because we're putting Tableau on the environment that is given to us, even if we don't fully control that environment. If you have active scanning, you want to look at when you can schedule it and do so thoughtfully. So using LogShark, you can look at what times on your server are the most busy. If you have a single geo for your business, 2 a.m. is generally a safe bet that you're not going to have too many people in the office trying to load Vizzes. That's a good time. If you have multiple geos, using LogShark, you can find when are the lulls in traffic and work with IT to see if you can schedule the runs for those times. Because generally, policies say scans have to happen once a day, once a week, but it isn't so concerned with what time of day that's running. So by talking with them and scheduling it for time that, frankly, no one's there using the tool, that really can make an improvement. You can also, if possible, exclude Tableau and Windows directories from these scans or the filter drivers, especially with filter drivers. If it's scanning other pieces of code that aren't run frequently, that aren't a part of Tableau or the operating system, that makes a big improvement. So you're still staying secure from other things installed on the system, but you're not getting in the way of the everyday code that needs to be run. Now, if you want to learn more about our recommendations about remediation around antivirus, there's a great white paper. Again, you can scan the QR code. Links will be available in the deck. So to close out, I just want to wrap up with parting thoughts about what we discussed, things to remember, and things that we can take back with us to our organizations on Monday. So the big one is that you have to be able to detect it to do anything about it. Just knowing it was kind of slow at some point, that's not generally enough for us to make a lot of progress. The other thing to remember is Tableau is doing a lot of work to support our viz loads and our extracts and our other jobs. The other important thing is that LogShark is awesome. I know it was just one line item of a whole section, but it made such a big difference in my career at Tableau, and I think you should all definitely download it and give it a shot. And Tableau can be tuned. I talked about some of the settings here in our documentation. There's many more things that you can tune depending on your needs. But also it's important to remember we want to tune our environments. Tableau is an application that's running in a network on our machines, and we may not control all of those facets. So that's why in the beginning I was asking what roles we all play, because we have to go and work with the people who fill those roles to make sure that Tableau can run efficiently and smoothly across the board. Now, Sid and I would like to thank you all for coming here today. We're so glad you could come. Please also, thank you very much.